if you want to know about the details of the words, you can have this one. So you can go these topics to see about the different types of networks and these things. I have made slides better, but I suggest you to go through these texts so that you may know some words in your mouth so that you can explain it. Whenever something is asked, you should explain. I'm explaining most of the things here, but in parallel you should go. So these are the, I have summarized in this slide, summarized the overall content of the transfer learning. Now, initially we have shown the same. I have shown the sample, which is just loaded the VGG16 model, and its structure is that layers are freezed. It has 5 convolution layer, 1 input layer of shape 24224, then 5 convolution layers, then 5 dense layers, and then output layer for 1000 classes. This is the default, you can say, the output or loading of a VGG16. You can load VGG16 with weights and without weights. If you are loading the with weights, it means you are freezing the weights. And if you are loading without weights, it means you are using the VGG net without freezing the weights. So I hope you can understand this one. Is there any confusion here, class? No,
No,
I
sir.
assume it's easier. So you can load the model with and without weights by having just one command. I have in previous class, I have shown here. If I say go into the top, I can show you here. You can have weights here. You can load the model without having weights. So if you do not load the weights, here I can see this, I have loaded the weights, but you can load it without having weights. So you can load it in both of the types. I have loaded the weights here. In this one, I have just, this is then shows the summary of uh, what you call VGG16. So this is the pure example that I have shown here for the first one. The second one is in second sample of the same code. What I have fine tuned by 3 methods. You can make any combination of fine tuning. In the first example, I have fine tuned. First of all, I loaded the model with weights by changing the shape. You can see here, I have changed the shape. Load the model with weights by changing the shape. So I just change the shape and load the model. So, and then show the summary of the model. Summary is nothing, just shows the structure of the model. Now class, then afterwards, 5 convolution, I extracted the features from the 5 convolution layers, last layer, 5th layer, where I have shape was 4, 4 and 5, 5, 5, 1, 2. I have extracted the features and then create another model of only for dense layer, and then loaded these feature into this dense layer model and trained this model for 2 classes and got 89% accuracy. So this is the way the first fine tuning I have worked. In the second fine tuning, what I done is I have loaded the model with this shape and then frozen the 5 convolution layers and then added 2 layers into the without feature, no feature extraction, but added 2 dense layers and dropped the and then output layer. By having second fine tuning, I have accuracy of 86.6. I have trained this model with convolution layers. So convolution layers are not trained, but they are added with the dense layers. By default here, dense layers are there. I have dropped these dense layers and the output layer in second one. So you can train the model and got 86 accuracy. The next one is third combination is you just freeze the first 4, 1, 2, 3, 4. First 4 blocks of convolution layer, you have frozen the weights, while last convolution layer and the dense layers, weights of last convolution layer and dense layers are unfreezed and trained the model for 2 classes. So this is the way I have used 3 different fine tuning methods and show you the graph in the previous class. I hope it will be clear. It must be clear. I have shown the graph in previous class Right now, this is something different. This graph is something different. So I'm just, for revision, I'm just repeating that what we have done in the previous class. This is the overall things we have done in the previous class. These are the graphs with the first fine tuning. This is the graph with second fine tuning. And this is the graph with third fine tuning. So you can also show the graphs for loss and accuracy as well. And this is the last fine tuning has been smooth. These graphs has been smooth to show the results in such a way. Now, in feature extraction, I have explained already. The feature extraction is nothing just to get the what you call it, the output of the convolution layer. Here I have a convolution layer, so I have taken the output of the convolution layer and assumed as a output feature from it. Now you have so many here feature extraction, what you call it, transfer learning or pre-trained models. You can use any one, but may avoid to use layers more than 19. 19 and 20 are enough for your PCs. For 19 layer is more than enough. When you go for 50, it may be hang. So you can try for 50, but make sure that they can be loaded in your PC. If your PC has enough RAM, you can load ResNet for 50 layers, even though there are so many other pre-trained models of 150 layers, but you cannot load them. If you load them, your memory is completely occupied, so it will create a problem for your PC. So you have to shut down the PC or restart the PC. So for this purpose, you can use any one exception. Maybe see the structure whenever you are using any transfer learning model. See the number of layers, how many layers it has, convolution layers and dense layers. Especially forget about the max spool and dropout layers. Just count the convolution layers and the dense layers. You can assume that how much time it will take or how heavier this network is, how much deep it is. Afterwards, the next, after this all, I have added some text to stop the model as soon as it gets the best weights. So if I say here, the last option, I made it false. According to by default will false. Whether to restore model weights from the epoch with the best values of mentioned monitored quality. So you can make it yes. By default, it is false. So if it is false, then weights will be of which layer? Can anyone tell me? If it is false, then what about the weights? Class, I am just calling the names. Yes.
So last में अच्छा अच्छा
Oh, it's better because I want to know the rest. Okay, Mashuk Ali, can you tell me if I do not, if I see, if I have this option is false, then weights of which layer you will have, which epoch you have?
No idea, sir.
No idea. So you are supposed to ask. If you have no idea, you are run the code and try for these things so that you know. If I ask an examination, then it will be hard for you. It will be hard. Then Aksa, can you tell me?
Sorry, slides are not visible. Font is very low, and also code's font is very low. I can't see it.
So you can open your download it from your LMS and you can open it. It's already
Yes,
there.
sir. Yes, sir. I am doing the same. Yes, sir.
So you are supposed to make it before the time. Yes, Ashish.
Yes, sir. Sir,
Can you tell me
of the last trained epoch,
why?
sir, because it's not best fit. As we put the line on the best fit epoch, but we are not restoring the best weights we are getting.
Okay. Now, if anyone is still unable to understand, I repeat the words that uh, he repeated right now. I repeat it again for you that if you are not, if you are stopping early, if you are stopping your model early, suppose you have given 100 epochs and your model is stopped at 50 epoch. So when you use this option, it is possible. In previous class, I have shown this one. The model is stopped before the time, before the completion of all epochs, if you use early stopping callback. So, and you make this parameter as a false, it means you don't want to store the model who has the best weights. It will store the model of last epoch. So when you make it true, it will store the best weights that you found by using this one. So actually you will not get the benefit of this one if you are not making it true. So back to the code and try to run it class, making it in previous class, I did not make it true. So can we, if your PCs and code is there, just run it, make it true. Like here I have, so make this value true, and then you can run it. So you can run it for callbacks. I try to run it if it is possible for me here to run it with the true. Can you run it so that show me the results are different from the previous one? You can assume, you can find out. If you make it false, the result will be different. If you make it true, the result will be different. So just run it and let me know, is it any difference in the results? Especially the last
Okay, sir.
fine tune, especially for the last fine tuning. The last fine tuning have different results. The last fine tuning is what? Last fine tuning is freezing off, unfreezing of fifth layer and the dense layers. So just run it and let me show the results. Is there any difference between, because I cannot run it, I have already executed some code here for you for the next class, for the next example. So I'm not want to run this one. Is there any difference? You just let me know. What is the accuracy before and what is the accuracy or after applying this parameter? Anyone from the class?
सर ये मेरी आपने एब्सेंट लगा दी है, मेरे लैपटॉप बंद हो गया था, लाइट चली गई थी,
नहीं लगा दी थी प्रेजेंट मैंने।
वही हुआ था।
आपको मैसेज आया है क्या?
नहीं मैसेज नहीं है, मैं क्योंकि मेरा जब नाम आ रहा था तो मेरा लैपटॉप ऑफ हो गया, तो
मैंने उस पर प्रेजेंट लगा दिया था।
ओके सर, थैंक यू।
Just run the code. I want to see the output of the last fine tuning. If this parameter is true and if it is false, then I want to see the difference between, is there any effect of having this one? So next is class, how to load the model and make the classification. So you are supposed to load the model. How we are going to load the model? Before, once you stored the model but did not used, so it will return the best weights from the model. Once you save the model, it will store the best weights. So how you can load the model is also today's class, included in today's class. So how you are going to, yes, you can load it, but right now you just use it by loading the model. I just one command to load the model. So I will write here, just add one command to load. I show you how to load it. So just put the one command to load the model from the hard disk. So it's just a one command. So once you store the best weights, and then you can load it and then see the results. So it's not the case that is difficult for, I just showed the Keras, how you can go for having the best model. So click on Keras, you will have help for the Keras. Keras, and then title load model. You will have a help here. So this is model save, and similarly you can have model load model, and then 5C, very simple one, nothing to worry about this one. So just copy. I just copied this one and then try to load the model. So you need the export and import, these two commands. So I just copy this one so that you can load it. So for the last one, where I have made the accuracy here, before evaluation, if I load the model, then it's better. Here you can type here class. Model is already stored. I think it is stored, and if model is not here, if I store the model, then just you can have, see this model is stored here, and then here where we have stored the model, we did not store the model for, this is something different. So here you have stored the model. Now, once you store the model, you can load it for, after drawn the graph, you can show the accuracy and these things. This is a predict. So see, the model is stored, and then you can load it. It should be here. Just make changes accordingly. What am I doing? I'm doing for the last one only. So once model is stored, then I have predicted on the data, and then once the model is stored, you want to load this model, just copy paste the load, and then you can have a stored model, whichever it is, it will be loaded. Type here, and then you have models already saved. So load model should be here, and then use the same name so that it can be loaded. And then you can run it, class. Just run it by having these 3 lines, how to load the model. By having just these 2 lines, you can load the model. Model is saved and then loaded. Before saving, you must make the parameter true so that it will store the early stopping, the best model for the last. So once it is done, then you can see the results before and after the code. Is there anyone who loaded the model? If I run it, I will lose these results. So I think I'm going to run it. Okay, let me run it for clear. Okay, class. Variables and plots are clear. I'm going to run it and then store it for is first of all, it will extract the features, because for 3 types of fine tunings. So it will take a little bit time to extract the features. and then 4 types of fine tuning and their results. I have executed. You can execute just by having these two commands to can load the model. Yes, class. Is the code is running?
Yes, sir, it's running.
So have you loaded the model? No.
Yes, sir, exactly. We are on the same output, like it's extracting for the training features.
Hmm. You can have just this one. Just these 2 commands can help you out to load the command. But before loading, you must save it. So option I have shown already. I'm showing again the option. You're supposed to make it to this one, restore best weights. If you are using early stopping, use this one as 2. And keep in mind, we have made our learning rate 0.01. So, and it will stop if it is not decreasing more than this one. So I've explained in this previous class. Just right now I am making it. So there's a little change in the previous code, not the major one. So just make changes and then load the model. Similarly, you can load model everywhere, wherever you have. I have just loaded in the last because I want to see the change in the last model. That's why I've done this. But you can load it wherever you have a save command. So if you have save command anywhere, you can just load it. See here, the model evaluated is there, fit generator, the model history is here. We did not save the model here. If you are going to save the model, then you can load it. We did not save the model over here. So I cannot put this command. Yes, this is save here, model saving. Now you can load it. Suppose it is 3, so you can make it 3. So you can load the model, best model here. So once the model is saved, then you can make predictions after the loading. Once a model is saved, you can make predictions, not before, because you are saving the model and then loading the model and make prediction on the best model. So you can have this one in such a way. So go back to this one, how you can takes longer time. So maybe see here, it is 100 epochs. So it may be due to early stopping, it may be stopped, because if the loss is not decreasing, then it will make early stopping. So that's why it will not run longer and then gets the wait.
अच्छा
Yes.
सर हमने यहाँ पर हमारे पास उनके टेस्ट के लिए हमने अलग से डेटा रखा हुआ था पूरा, मतलब हमारे पास एक पूरा फोल्डर पड़ा हुआ है, तो हम उस पर यूज कर रहे हैं। हमारे पास जो प्रीडिक्ट के अंदर हम इनपुट दे रहे हैं वो टेस्ट जनरेटर मेथड दे रहे हैं एक, तो वो क्या करता है, वो बैच वाइज जो है वो टेस्ट डेटा लेके जाता है, जैसे वो वैलिडेशन का और ट्रेनिंग का लेके जाता था। तो सर अगर हमारे पास सिंगल पिक्चर हो कोई डैग और कैट की, उसको हम कैसे करेंगे?
सॉरी, मैं आपकी आवाज कट रही है, इस वजह से मैं क्वेश्चन समझ नहीं पा रहा। आप क्वेश्चन रिपीट करें, लास्ट क्वेश्चन रिपीट करें ताकि।
हाँ सर, अगर हमारे पास सिंगल पिक्चर हो डैग या कॉट,
I cannot hear you properly. I cannot hear you properly. I cannot hear you properly. आप टाइप कर लें क्वेश्चन। I cannot hear you properly. There's a disconnection. See, the first model is disconnected here. Now early stopping. So early stop and then shown you the results and the accuracy, test accuracy. It's early stop and shown you the test accuracy. And then next is again second type of, even though I had not loaded the model here, I just made it as it is, but you can make the model to load for each time whenever you are saving. So once the model is saved, you can load it. See, it takes longer time. So till that, I think let it to run and then see how it's saving and executing the model, so that we can jump on the next example. And then we will run it later on. So I hope it will work. Is there anyone who finished the training process? Is there anyone?
No, sir, it's still extracting.
And which one thing more that you can make it class, to split this code into 4 parts. Version, you can call it fine tune 1, fine tune 2, 3 and 4. So for fine tune 4 it will be easier, so because it's not dealing with the feature extraction. So for practice you make it in 4 parts. Fine tune 1 is purely for the slide as I shown you here, and fine tune 2 for the next one. So it will be easier to handle as compared to the, if you go for this one, make each program different for this one, for fine tune 1, 2 and 3. And then just we will run for the last one. So if you make it, it will be a little bit faster. Now next is class, it is about the how to saving the model. I will put the slide here to save the model, how you are going to save the model. For your ease, I am going to load model. Load model, you can just have a help from here. You can load the models once you have saved. So you can go help from the Keras directly. I have just shown you the reference here so that you know how you can use these callbacks for loading the model. Okay, class, back to here. Back to the code. Maybe it takes longer. I hope it take longer because there's a training of large number of epochs. So validation accuracy is okay. Class, let it run the code. Then I have to explain the next one so that we will run this code afterwards. Now, next is class is all about how you can work with different. Let me just show you. Now, these are the things that have high effect on your results. I've given this assignment already uploaded. So take the same cats and dogs example, and then you can use any pre-trained networks, and then select any one by showing the results, and then show the effects of augmentation. Apply the augmentation by using fine tuning. Apply any one fine tuning methods. I have given 3. You can use any one, and then show the effects of augmentation. Same fine tune model with and without augmentation. So select the best. Usually it is augmented method, and then use different optimizers, and then you can use and then select the best optimizer. Similarly, use the effects of LR, that is learning rate. So today I'm discussing about the learning rates. What are the effects of learning rate? And then show the effects momentum. Use the different momentum. You can see the difference. Choose the best momentum. And then last one, show the effects of decay. Which methods you apply to reduce the learning rate while training. Today, my focus is on this one. But and the last one is patience. How long your model can wait for searching the least loss. Right now, the patience is here. You can see the patience is 7. In this code, the patience is 7. So patience is nothing, just to wait for how long, how many epochs. The model will trained once you get the lowest loss. Suppose you got the lowest loss 0.1, and next consecutive 7 epochs, the loss is not decreasing, the model will stop training. So this is the patience. So you can check the patience. Sometimes patience is low, small number of patients can have better result than the bigger one. So start from 1, 3, 5, and 7. Sorry, the patients may be start from 7, 5, 7, 9, and then similarly you have 3 or 4 patients. So select one patients, and then you can have best results on anything. So you can try this one on cats and dogs data, and then finally you have best results, and you have all the parameters will be fine tuned. All the parameters will be, you can say, optimized. So this is the way to optimize the the neural networks. So by having this assignment, you will learn how you are going to optimize the hyperparameters. So after Eid, you will submit this assignment. So by showing results in PPT file and a code over there. 2 files are required and to be uploaded on LMS. Now this is a sample I've shown you. You can show the results when you apply different learning rates, different momentum, different optimizers. These are different optimizers with different optimizers. So choose which one is the best. Here, choose which one is the best. So similarly, you can apply the best parameters to your model and get the best results from the model. And the last one is decay. Which decay has the best results? And this is the which type of decay you use. Today we are discussing this one. There are 4 types or 3 types of decays. These are the patients. 2 patients shows the better result. 5 patients, 10 patients, or 15 patients. So choose the best patients value. While this is, we are going to discuss today for this decay, how you can control the decay while training, the learning rate decay. See, this is an example. Today I will run it and then show you what's the difference between these 4 methods I have applied to reduce the learning rate while training. The first method usually we keep the learning rate constant throughout the execution of the code. Normally we are doing this. अब तक जितनी भी example हमने किए हैं, उसमें learning rate constant रहा है. We are not reducing the learning rate throughout the code, throughout 100 epochs हैं, तो learning rate same ही है. So learning rate should be changed. Learning rate is nothing, just a step towards the local minima. So if you are near the local minima, then these learning rates should be reduced. If you are away from the local minima, then learning rate should be bigger. So it will affect the output of the model. So that's why which method you will select for having effective learning rate reduction method while training. The first result is shown. See the same data, same code, the result is entirely different. The first example is showing when the learning rate is constant. The second example of the code is showing when learning rate is reducing by the time, means after each 10 epoch, it's reducing by 0.01. And then step decay is nothing, just when you have some calculations on if it is not reducing 0.01, then if the loss is not reducing by some certain value, then you are supposed to make it higher learning rate reduction. And the last one is exponential. So you can have a different value on different epoch based on exponential formula. So these are the 4 methods you can reduce the learning rate decay. I'm showing this example once I get the results of the previous code. So here you can see it's still running. It's too slow. Maybe here. Yes, it's taking longer time to stop the training. What about your results, class? Is there anyone who finished the running of this previous code?
No, sir, it's still running.
And which one? Which fine tuning?
70 epoch, and I am on 46.
The first fine tuning?
Yes, sir.
So it will take longer time. Here I have little bit faster machine, even though it takes longer time. So I have to reduce the number of what you call it. Input size can be reduced. If you reduce the input size, the execution will be faster, but results will be compromised. So it will take longer time. Class, keep your program run.
Yes, sir.
And then I will share this code. I'm stopping this one because right now I cannot make longer waits for this one. So you can run this code. I think you just make these 2 changes and then run the code. I repeat, in this code, previous code, make the first change is make the best weights with the model true. Restore the best weights model true. First change is this one. The second change is wherever you store the model, just load it and then evaluate with the test data. Evaluation would be after loading, not before the loading. So it should be after the loading so that you can use the best model. Otherwise, it will show, if I show this one over here, it will produce the results of the last epoch. So we are not interested in the results of the last epoch, but we are interested in results of best model. So you can use it in. So just these 2 changes, even though I will upload this code after this class. So I'm back to my example, which one is today's lecture, and then we'll back to the.
So
Now
can you
class.
share this file, updated file?
This one, okay. I'm
Yes, sir.
sharing on an LMS or directly on.
Whatever you prefer.
Okay, I'm sharing this one on LMS so that.
Okay.
Let me go for LMS. Already it is somewhere. Here it is here, code it is here. So I'm sharing here for that. Today's code is already shared. You can download this one class, Python code for learning rate decay types. Download this code. I'm going to run this code right now. Everyone download this code.
Okay, sir.
So the previous code I'm uploading here for transfer learning code. So I'm uploading here. Not here. Can you see? I want to see the code. Code is 5.3 using a pattern. 5.3. I think this is the code. Am I right? Is this the code?
Yes, sir.
But this time is not previous time. It's another code. 5.3.
No, sir, it's another.
Yeah. Let me check 5.3 where I have stored this one. Let me check the path from the code here. Which one is the path here? This is
Sir, over का ही बात आ जाएगा.
show in external file explorer. No, it is option here. This is cats and dogs. Now I'm showing path नहीं show करना, मुझे इस पे folder पे जाना है, तो इस वजह से directly I can jump in here. I have show in the external file folder. It's there. So this is the code. Yes. So this is somewhere else. See. So I have to upload this one into copy and then make it cats and dogs here. No, this is the code actually that I wanted to upload here. Okay, let me save. Now you can download it. It is there. You can download it and then download both of the codes, class Python
Yes,
code
sir.
for learning rate decay, and then can you see the screen, my screen here, class?
Yes, sir, it's visible.
Yeah, so just download these two codes, and that assignment is here. You can see assignment is here. When you click over here, you will have a sample of how you can show the outputs. And this is the code and data set previous code. So everything is here. If something is missing, you can just accept the videos, just because I need some space to delete the previous videos and then upload this one. So this is, so I will make it very soon, inshallah. Don't worry. Just run this code so that, is there any other query, class? I have seen some text, but I think it's loading of the model is there. So no need to worry about it. It's very easy, not difficult one. So whenever you want to find a new thing, just go to the Keras help and then it's not, is it confusing, class, to load the model? I don't think so. It's easy to load the model, but once you load the model, then show the results. Make sure this one. If you make this one, maybe if I make copy here, class, the results may be different, because here it shows the results of the last epoch Here it is showing the best stored model. So it may be different. So keep in mind which results you need. So make it accordingly as you need. So it's not stopping here. Can I stop this one so that I can run the next code so that you will see the output of the code? I have shared the code, run it, and then see the output.
Okay,
I'm
sure,
stopping
sir.
this. It takes longer time, so I cannot wait that much longer, because see, it's not stopping. Even though the validation loss is reducing, again it is less 115. It 115 is this is a minimum loss here I have. It means it will run for 7 epochs more. 1158 here I have this one. This is the minimum loss 0.94. 1 2 3 4 5 6 7. Maybe this is the last, maybe, because thus I have here reduced this one. Yes, see, this is reduced. Yes, this is the least one. Am I right? So it will run 7 more, 5 more epochs, because this is the least one. Because I have applied, it will run, it will search for 7 epochs for minimum loss. So there's no minimum loss. There's nothing less than 0.555. There's nothing less. So it will run 3 more epochs if there's nothing. So just wait for, maybe it will show the better results. I'm sure previously we have this result 74 point something, but in here I have results. I have not shown the results. You can calculate the accuracy by having this one. Here, this is the results without loading, because this is the last, I think, fine tuning. It will take longer time because I have trained the convolution layer as well as dense layers. So it will be longer. One thing more I want to share you, class. You can take the features from any, suppose I have taken the features from 5th convolution layer. Now you can do this. You can take the convolution layer from the 4th layer and send the and then load the features of the 4th layer into the newly created model. It will be faster, because when you, are you getting my point, what I want to say?
No, sir.
First,
Can you please say it again?
first model is very faster in training. Why? Can anyone tell me? First fine tuning is faster in training. I'm showing you here. Be logical, because if you understand this one, then
सर
you will
पहले
be
जो
able.
वेट्स थे वो तो हमारे मतलब डिफाइन थे ना, हमें मतलब कांस्टेंट थे वेट हमारे. सेकंड में फ्रीज थे वेट. जो लास्ट वाले हैं तो वो फ्रीज नहीं है मेरे साथ.
ये बात ठीक है, मगर इसकी असल वजह ये नहीं है. असल वजह इसकी और भी है, जो मेन वजह है. सी हियर, ये बहुत फास्टर है क्लास. फर्स्ट फाइन ट्यूनिंग, ये ट्रेनिंग बहुत फास्टर है. बाय सबसे स्लो ट्रेनिंग इसकी है. ये कुछ स्लो है, ये फास्ट, ये स्लो, ये सबसे स्लो ये है. इसकी वजह क्या है? एक वजह तो आप कह रहे हैं कि वेट्स में अनफ्रीज कर रहा हूँ, ठीक है. इसके अलावा वजह है एक.
वो फीचर एक्सट्रैक्शन की सर, उसमें जो मेन फीचर्स हैं हम उन पे अप्लाई कर रहे हैं.
नहीं, एक और वजह है. ये तो ठीक है. इसकी वजह ये मैं बताता हूँ मैं क्या है. लिसन क्लास.
Shape, sir.
Mainly-
Shape.
No, not shape. Now see, वजह ये है कि we are not training, we are not performing in this first one, we are not performing training on convolution layer here. यहाँ पे convolution layer training में involve नहीं हो रहे. Am I right? सिर्फ कौन से layer train हो रहे हैं? Dense layer. That's why this is faster. See, we extracted the features from convolution layer and trained the separate model. Are you getting my point, class? In
Yes,
this
sir.
here,
Yes,
what
sir.
we are doing, we are adding 2 layers into the pre-trained model, output layer to the pre-trained model, and training the entire model while keeping the weights over here freezed here. So it takes longer time, because the image passes through all the layers and then train the model. Here, entire model is trained with untrained model, with frozen weights. While here, there's no concern of these weights to be included in the model. So that's why it is only dense layer are training here. All 5 convolution are freeze. So it is little bit faster than the last one. But is here and the last one you can see, Carl, what here you are training the last layer, you are training the dense layer and the output layer in all, combining the all. So that's why it is slowest one. So what I'm saying, you can create the fourth one. In fourth one, what you want to do, you will extract the feature over here, extract the feature here, and then create a separate model like this, feed the feature to this one, and then train just this part. It will be faster. Are you getting my point, class? Class, can you see?
Yes, sir.
Yes, sir.
Can you understand what I wanted to say? The fourth fine tuning method.
No, sir. Can you repeat fourth one?
Yes. If you understood the first one, everyone understood the first
Yes,
one.
sir. Yes, sir. First, second.
So now do extract the features not from the fifth layer, extract the features from the fourth convolution layer and create a model, have 1 convolution layer and 2 dense layers, and then train this model. Is it clear now?
Yes.
So it will be similar like this one, but will be faster. Am I right?
Yeah, yes, sir. Yes, sir.
Yes. So this is the way you can have same accuracy, but with faster execution. Is it clear? Because convolution layer takes time. So I hope it is stopping. See, it is stopped here. You can see here, it is early stopping is here because it did not find the loss after this one. This is the minimum loss. And the weights are stored, and then we have this one results here. So can I go the last one where I have this one is here, class. So it is just let to where the model is here. Here the model is this one. We have to we can use predict generator so that it will be better for, let me to just this one. Now class, I'm loading the model for last one model. I'm loading the last model, and then because I had not made changes here, now I'm loading the here. You can see here, I'm loading this model now. This model is already loaded and just show the accuracy here. So I want to see the see, it is 90% accuracy, class. Can you see here? The best model
Yes, sir.
has this accuracy. Previous class, you can see here, this is the accuracy on test data. This is the accuracy on test data having predict using the evaluate generator. So you have, and then loss is, you can show the loss as well. So if I say, how can I see the loss? I have this loss, and then if I print this loss, just put it here. See, loss is 0.199. This is the loss for this one. Similarly, if I load the above model, previous model. This is the fifth, when I trained the fifth convolution layer. So when I train just dense layers, so I want to see the accuracy here. I want to load this model. See, this model is already saved, and I want to load this one. So see, is it, once I load this model, I'm loading this model. See, this model is loaded. And then I want to see the accuracy of this model. In command prompt, you can do it directly. It takes a little bit time. Now I'm showing the accuracy of which model? The second fine-tuned model.
Okay, sir.
I'm showing the results. .374. When I just trained the last dense layers, the accuracy is this one. Are you getting my point, class?
Yes, sir.
So it's with the best weights. So you can show the results without having the best weights and with the best weights. So I assume that you will go for this one and show the accuracy on both of the models. Which model? First accuracy is of the last epoch, and second accuracy if of the best stored model. So this is the best accuracy. I'm just printing the what you call loss of his one. This is 0.53 loss. This is the loss 53. The loss is higher, the accuracy is smaller. Here loss is smaller, the accuracy is higher. See, so this is directly correlated. I think it's a little bit clear now. So I made this the code according to the need, as you can run it and then see the code results, so that first model, I think I did not save the first model. So try to save the first model. Did not save. Yes, it is saved. It is loaded for, this is not the first model, it's a 3 model. And then we have to store first model. Where's the first model? This is the fit. It should be saved here. Model should be saved here so that you can run it and use it. So let me to save this model as 1. In this code, I have not saved the model. So class, the first model needs to be saved. The model save with, this is, you call it 1, or you call it 1, yes, or 2. This is called a 2, and then load the model by 2, and then no need of, yes, here this one. And then what is evaluate, because you cannot evaluate this model directly. Why, class? Can anyone let me know why you cannot evaluate? Because you can evaluate just the features. So get the features where you have. You just evaluate the test features. So keep these features. You cannot use generator here. You use the model and then use this one, and then use the evaluate. So I make it stop here. I will run this code again to predict the model for 100 epochs. I want to run this model again. because if you extract the features, it will take longer time. So I don't want to involve this code to extract the features. So I make it and then run it without having the features to load. Now I want to run it for yes. Okay, class, I will run it later on for the next. I've just shown you this data and then I will upload this code. You will run it because it takes longer time. Now today I'm going to start for the next. See, this is the class. This is for how you can control the learning rate. Especially learning rate is very important. So this is the code I have shown you for, let me clear this all. Now, let me show there are three types of learnings we have. So just let me give you some theoretical concept first. So this is some concept how learning rate scheduler, how you can schedule your learning rate while training. So we have three methods because learning rate is nothing already told you class. If your steps are smaller, it takes longer time to train the model. If your steps are larger, then you will not be able to find the minimum local minima exactly. So it should be accurate. So to control these steps while training is actually because of this scheduler. So how there are three, we can have constant learning rate, that previous examples run on constant learning rate. So there's no change in learning rate. Next, we will learn time-based decay, means based on the time it will decay, then step decay, and then exponential decay. So let me to run these four steps and then explain you the theoretical concept. So I have these. The first example is a constant learning rate. And the second example is showing step by learning rate decay. And the third example, exponential decay. So let me just explain first what is the scheduler. So this is just nothing to plot the graph. And then this is nothing, just load the data set and then normalize it, nothing else. Just load the data set and normalize it. This is a root module to show the graph of different learning rates. Now here we can just, this is the, I have created the model of dense layers, just a dense layer model created and showed the summary. Yes, I previously done in so many classes. So model of just dense layers. There's no any convolution layer. Afterwards, what I have done here is to try to control the what you call here. I have compiled the model here. Then I have started what you call it, training in this. Now by default, the training uses the static kind of learning rate 0.01. So it will remain static while training. So can I see, just flip here, and then you can see here, is there any learning rate? Learning rate will be constant. Whenever you use, learning rate remains constant 0.01. So this is the learning rate that remains constant here by SNGD. If I say here, learning rate is default, and SGD learning rate by default 0.01. If you do not, usually we do not provide this one because default takes 0.01, but you can change it. Till to date, whatever the examples we have done has learning rate 0.01, this default value, but this is not the good practice, and momentum is 0.0. So I suggest this is not the good practice. So whenever you are working with your model, you should optimize your momentum value and the learning rate by using this command. So you can try different values and then get the optimum value for learning rate and the momentum. Now class, let me just explain how you are going to make this value change. So initially, I kept it similar as we have in previous examples and shown you the results by having just fitting the model on the MNST dataset, which is what? Which is the digit dataset, and then created a dense layer model and then shown a graph. So till that point, so I can show you run by using constant from here to here is nothing just to share the constant running. So I just put it mark here, put it mark here. So they run the code till for just for one. See here, I have just executed for one only to show you. So it is of 50 epochs. It's running for constant learning rate. There's no learning rate changing while all epochs. In all epochs, the learning rate is constant. There's no change in learning rate. So if the learning rate is constant, it means and then momentum is zero. So the next one, in the next step, where execution will stop here on the red point. In the next step, when can I show you the plots here? In the next step, it will run for uh, time-based decay. So let me just see the 50 epochs here, how it will the result difference in all these. I have already examples here. I shown you the examples for. So it will show the graph like this class. You can see here, it will the first graph will be there. It is constant learning rate. You'll see such kind of graph here, and then we have second, third, and fourth. So let me show the first. See, you have this graph. This is the accuracy of the model on constant learning rate. You can see here, this is the testing loss, and this is the accuracy of on testing data. 83 accuracy with this loss. I've shown the results by having these commands. You can see here, class, I will show the commands as well by maximizing this code. You can see here, I have shown this result by this one. Now I'm stepping for the next one. See, I have just drawn the graph and then evaluated the test data using the uh, these models. So these are the results from first model, first constant learning rate. When I change the learning rate, now in this one you can see time-based learning rate. In time-based learning rate, what we are doing, we are dividing the learning rate by epochs. Every time what we are doing, we are dividing learning rate, suppose 0.01 divided by number epochs. How many epochs are there? So every time learning rate is divided by epochs, and then we have learning rate decay per epoch. The learning rate decay per epoch, and then we have accuracy. So for each epoch, you have different learning rate. So you can see here the learning rate will change. I will show you the next step. So I'm running the next one. You can see here, see the learning rate is changing for each epoch is different. So if I use the verbose one, see the learning, it is verbose one, or if I use verbose one, then it will show the, see it's verbose one here for this model training. So it is the next, is changing the learning rate on depending on some formula that is after time based. Some time means based on the epochs. So this is the second graph we are looking at, class. Is it, let me, I think it's, I have run the same example again. So let me just stop this one and run the code entirely so that it will stop execution by having Here, the learning rate is changing with different, see? The first graph is without changing learning rate. The second graph, we have changed the learning rate on each epoch. See, it is changing. On each epoch, you have different learning rate. On each epoch, you have different learning rate. See, showing the learning rate. Now you have accuracy is 85 here. Afterwards, third one is on, you can see third one is based on step decay. Means stepwise, it will, if it is not, if the accuracy after 5 epochs, it will change the learning rate, fixed one. After each 5 epochs, it will change the learning rate. So this is the way, see, learning rate will change. See here, learning rate is changing. This is after 10th epoch. When you jump in the 11th epoch, learning rate is changed. So this is what? This is your step decay. Step decay is nothing. You have fixed after each 10 epoch, the learning rate will reduce. So this is your step decay. So it's after 10, see, this is 10th epoch. When you are in 11th, the learning rate has been reduced from 0.01 to 0.005. So this is a step decay. So it is applied and shows the result of after, then you can have 40. See, you have 40 different, and then 41 you have different. See here, 40 you have learning rate is 0 point this one, and then see here it is changed, and it's constant for next of the steps. So it's depend on the, now these are the results. You can see I have 4 methods I have tried. Show the graph first. The first one graph is for constant LR. Second graph is time based. Third graph is for step decay, and the fourth graph is exponential. So I'm showing you the details how I made this one. The results are here for last 4. See, we can see first the constant learning rate decay, we have lost 0.36 and accuracy is 86. See, and the next one time based delay 0.4, loss is, and then accuracy is 85. Next step decay, you can see loss is 0.3611, accuracy is 88.41. Here you can see little bit improved accuracy by having exponential decay. See here. Now class, these are the 4 methods I have applied just for learning rate decay. There's a change in accuracy from 86 to 88. You can see 88.5. It's 88.5. This is 87 approx. So 1% or 1.5% accuracy is increased just by adopting the best decay rate. And one thing more I suggest you here, I did not stop the model on the best weights. So when you apply early stopping with exponential learning decay, you may have better results. Are you getting my point, class? Is there anyone who understood this one?
Sir, voice is a little missing, but yeah, we got your point.
I repeat, when in this example, I have not used early stopping. I did not use the early stopping. I just use the learning decay. So if I use learning decay with early stopping, I will get better results. Isn't it?
Yes, sir.
Yeah. So I'm just teaching you the different options. So when you go for your code, you merge all these best practices. Is it clear, class? Okay. Now let me explain these decays little bit with definition. So back to the text. I have just given you this code. I will upload this code so that you can run it and then understand what are these decays are. I have just worked with one parameter, one hyperparameter, that is learning rate decay. Similarly, you can work with momentum because I given the assignment. So you can work with momentum by having 3-4 values. See which momentum has better output. Can anyone tell me what's the benefit of using momentum? Yes, Mohammad Wakar. Can you tell me what is the benefit of having momentum? Right now, momentum is 0.
Sir, I think when we increase the learning rate, so
No, momentum.
Sir,
momentum.
it increases training speed and accuracy.
Not training is speed exactly. Anyone else? What is the goal of? Yes, Iftikhar.
लोकल मिनिमा से
ये
बचने के लिए सर
Yes,
ग्लोबल
good.
Correct.
Excellent. When you have three local minima and one global minima, if your momentum is low, your learning will stuck in local minima. So by improving the momentum, by increasing the momentum, you will not stuck in local minima. So this is the benefit of having momentum. I already explained the previous class. So you cannot, here you have only one minima. But what will happen if you have more than one local minima and one global minima? So you need momentum. If momentum is moving around the different local minima and reaches to the local minima. So it will help you to find the global minima quickly. You will not stuck in local minima. Is it clear to everyone, class?
Yes, sir.
Anyone who is still not clear with momentum and learning rate? Learning rate is the size of the step towards the minima. It may be local or global. These are the size of steps. Here, size of step is smaller. So it takes longer time to go the local minima or global minima. If the steps are very huge, you cannot find the local minima exactly. So your results will not be good. So it should be optimum. The learning rate should be optimum. So whenever you are far from the local minima, steps should be larger. When you are close to the local minima, the steps should be smaller. By this can be done by having which option? ये कैसे होगा? Class. Learning rate scheduler. I have made right now. अभी जो हमने सीखा है वो यही दिखा है कि लर्निंग रेट शेड्यूलर जो है वो आपका क्या काम करता है, स्टेप्स को ऑप्टिमाइज करता है क्लास. लर्निंग रेट शेड्यूलर इज very important for your, this is the learning rate scheduler. This is, I have defined here the learning rate schedule. Can you see this one, class? Can you see this one?
Yes, sir.
Yeah, learning rate scheduler क्या करता है class? It will optimize the learning steps. Initially, it will take smaller. At the end, it may be, initially it will be larger. At the end, it will be smaller. So avoid the constant steps. How you can avoid the constant steps? By having learning rate scheduler. When you use the learning rate scheduler, you will control the learning rate throughout the training. As I have shown here, I have different learning rates and different. See, this is learning rate 0.0097. Here it is different. It's reducing. Here it is reducing. See, it's reducing. Why it is reducing? Because we are nearby the local minimum. Initially, it is very high. See here, I show you. Initially, it will be very high. I have 100 epochs. In the first epoch, it may be very high. So you have different mechanisms to reduce the learning rate. 4 mechanisms. The first mechanism is you keep it constant. Don't change the learning rate. The second step is you can make it, the second step, you can make it time-based decay. The third, you can make it step decay. Step decay is what? I told you the step decay is after each 10 epochs, learning rate will be reduced. After each 10 epochs, suppose first time it was 0.01. After 10 epochs, it will be 0.001. After 20th epoch, it will be 0.0001. After 40th, it will be 0.00001. Similarly, you can reduce the learning rate after some period. So this is the step decay. And then exponential based on some formula. So let me here to show you these decays here. So the same example I have implemented and then show you when you are applying the constant decay, it will be like this. So constant decay is continuously you are reducing the learning rate. Okay, so this is the time based, or this is time based decay. So as soon as you are increasing the epochs, it is reducing constantly, it is increasing based on the per epoch, it is reducing per epoch. So this is time based. So when you're talking about learning a decay with a step based, after 10 epochs, it is reducing. After each 10 epochs, the learning rate is reducing. See, it is reducing after each 10 epochs. This is step decay. And the next one is exponential. See, exponential is nothing just a curve based, a formula based, which is a curve based. Initially, so this is the best method. In my opinion, this is the best method. Why? Why class this is the best method? Initially, you have longer steps. See, initially the learning rate is high. As you go to the local minima, it is reducing. Now it's static, very less change. Are you getting my point, class?
Yes.
This is what we need. This is what we need. This is exponential method. Here, this is static. See, here it is static. It is reducing, but here it is jumping. So jumping of learning rate may affect the results. Here you can see it is also something not reducing quickly, very slowly reducing, but with a constant speed. And always it is reducing. So it affects the results badly. It can affect. But when you talk about this one, last one, see, the steps are, see, initially it's very high. At the end, it's going to be smooth. So it will give you the best results. And after 60, or you can say after 40, it's not reducing because there's very less chance of you are nearby the local minimum. After 40, it's not reducing. So you are nearby the local minima. So learning rate will be static. So exponential, in my opinion, is the best strategy to control the learning rate. Is it clear, class, for today? Any confusion, any query, you can ask right now. Any query, class? No, I assume that you have learned.
No query, sir.
No query. Okay, so I hope this is a best example that I have given to you for this one, and I've saved the model, restored the model, and this one. Now I've given you one assignment or one practice question. Find out, you want to store model on each epoch. Find the code for this one and try in your model. It is also possible that you want to store a model for each epoch. It's possible. So if you need this one, you can make it. For each epoch, the code will store the model. And then you will search, test each model on the test data and find which one is best. So this practice can be made. I repeat, you want to store model on each epoch. Right now, what I'm doing, I'm storing the model on best weights, on the least weights. Am I right? The current code, that previous class code, is storing the model on best weights. But if you want to store a model on each epoch, it is possible. You can make it. So you can go and try to get practice for this one. I hope it's enough for today's class. And then from the next class, we will jump in. It's over for images. I hope you will be familiar most of the things you have done about the CNN of the images and the different options used for CNN. So there's nothing left behind, much more left behind for this one. I have tried my level best to show you the best practices for this one. It will help you in the projects as well. So now this assignment is for optimization of the parameters. So you will get 10 marks as soon as you will submit this one. Actually, I wanted to see how you are capable to optimize the parameters. In each step, you are actually increasing the model performance. In each step. Now, these steps can be shuffled. You can shuffle these steps. It's up to you, but they must be there. So what the target is, you want to get the best results by parameter optimization. So this assignment is towards the parameter optimization using transfer learning. So I want to have this model. The deliverable will be two things, the code and the PPT. PPT shows the graphs and the discussion, what which one you have, just 2 or 3 lines, why you selected this value and why you selected this option. So just give the option and then proceed these all steps. And then finally you will have a best model. You will have best accuracy, or you can say a best model, best results. You can have best results. So this is the goal of this is final assignment for this one. So you will have 10 assignments. So you can show the results like this. Is it clear, class? You can show the results like this. I have shown this sample for you. You can show the results on different values. You can try different values. You can show this one and choose anyone. Suppose you have did this one, the best one is this one, 0.01, choose this one. Or you can use the decay function that I have used today. You are not supposed to use these values. You can use the function as well. So this function goes the best result because these are the static values. So you can go for exponential decay. Today I have explained this one. Momentum, you can try 3 momentums and get the best results on which momentum. Similarly, use the optimizer. Which optimizer give you the best results? Choose the best optimizer. Similarly, you can choose the best patience, where you get the best minimum loss. So you can use the best patience over here. Similarly, here is a decay. You can use the decay, which decay is better. So you can have this overall optimization of the hyperparameters. This is called optimization of the hyperparameters to get the better results. So it will help you in the projects as well as in this code. So I hope this you will learn a lot from this one. I hope. Is there any query, class, for this one? I have ended the all about the CNN, about the images, about the optimization of parameters. Everything I have finished. I hope it will work for your projects and for future anything we want to jump into this field. Is there anything, class, that you want to ask?
Yes, sir. Please upload previous lectures, video recordings.
Yes, I will upload very soon. I told you because I have to clean my I have no capacity to store. That is the problem. First, I will delete the data which is already stored into the Google Drive, and then I can upload these videos. So
Okay, sir.
so inshallah before Eid I will upload very soon. I will upload. Don't worry. So let me just come up with after Friday I will be free, little bit free. From on Saturday or on Monday I will upload these videos. Till that you will just get practice for this whatever I have taught here. Anything else that class you will ask? Anything that you want to ask?
सर वो जो प्रोजेक्ट था हमारा पहला उसकी भी
इसकी
डेट
बात करें जो यहाँ पे इसकी बात करें. यहाँ पे मैं आ रहा हूँ. यहाँ पे this one.
Yeah,
You are talking about this one, class?
Yes, sir.
Now this one is actually generic one. See, you can use any I have here. See, this is also contains so many other things here. So many things are here. You can just go through anywhere. Now, right now we are just see normalization is here. I have not discussed any normalization for the data. So this is something generic. This is not the specific to the images. You can go any kind of data for pre-processing. Here, the main focus is pre-processing. You are improving the results by having pre-processing and show the graphs. Here, the main focus is on pre-processing, not on any model. You can use any model here. You can use any model here, like you can see here, histograms, and then perform pre-processing like normalization, and then accuracy, loss graphs. Training model can be any. You can use any training model, not necessarily classification. So next, maybe we have any other model for, suppose we are jumping to the clustering. So clustering, you can use the clustering for this one. So you can use any model for this one. So this is generic one. You can use any data set, but this one is specific towards the deep learning. This is towards the specific to the deep learning here. Here we have a specific to the deep learning, especially transfer learning, not deep learning exactly, the transfer learning. We are focusing on transfer learning. So the previous one was generic. You can use SVM anyone.
Yes.
You can use anyone. You can use it. But you can submit it later on. This one can be submitted later on, but this one should be done this one should be done on this date. Okay, for the previous one, you can take time. For this one, that is, I'm showing you here, this one. So this one take little bit time because we have so many things to do. There are so many things are here. So you can submit this one at the end of the semester. This project, you can submit at the end of the semester. But for this one, this is purely on transfer learning. So you can go for transfer learning and use this one. So this should be done because I was not assuming that there will be no mid two. If there was a mid two, then there's no need to go this assignment. So this is a replacement of nothing. You can say the mid two. So you can just submit this. So I can mark you accordingly. 10 marks are here. Anything else, class, that you want to ask? Anything that you want to ask? And then you can, for help, you can go for the Keras. You can see there's a help for the Keras. If you want to go for Keras, you can see this is the help. You can go to guide and see the help of the Keras. You have all the commands, all things are here. Get started. You can go and see the help of the Keras. So I usually take samples from the Keras to show you how you can use this one, the different models and different things that you are using. So I hope that you will go for the help. Anything, class, that you need help for this one? Any help that further you need? Let me to stop the sharing of the screen. Do I stop the sharing of the screen, class?
Sure, sir.
Okay. So any query you can ask. If you have any query till this point, you can ask. So I hope that you will finish this assignment by the time and then show the better results. You can submit 2 documents, the first one code, the second one PPT. You are supposed to submit 2 for this one, a PPT and a code on what you call it, on your LMS. So this is all about the today's class. If you have no query, then you can continue this one. I will apply the attendance. Right now I have how many students here? I can show you how many students I have right now here. I can show you the participants right now.
सर गयूर ने इन्फॉर्म किया है अभी 1-2 मिनट पहले कि उसकी लाइट चली गई, वो ऑनलाइन था।
हाँ ठीक है, मगर मैं अप्लाई नहीं कर रहा, इस वजह से अप्लाई नहीं कर रहा मैं। वही
जी,
वजह है, यू शुड बी। देखें, अगर मैं चाहूँ तो मैं अटेंडेंस सबकी लगा दूं। मसला ये होगा, व्हेन आई गिव सेम क्वेश्चन फाइनल एग्जाम, then you will get stuck because all things cannot be having easily understandable. You can ask the questions. If you are not understanding any point, there's any confusion, how you can go for see, I have 16 now out of how many? 19. So still 3 are absent. Maybe they have genuine issue. That's why I will upload. Yes, I will upload the classes. I will upload the videos, whatever I have. But you should be here. It's better. You can ask the questions. You can now for assignments, maybe they are a little bit able to understand. So I hope that you all will be here. Maybe someone have genuine reason. It's possible, but not for all. So try to be here. I will try. I'm trying my level best that I will deliver to all of you, so that you will learn most of the things. You will go for your final projects, not just for this assignment, not for this subject. So you can go for your final projects. Maybe you will stuck in your final projects. It will be helpful for your projects as well. So this is the thing that I don't know. I think for final year project, you are talking about which one? The assignments that I have given right now?
No, sir,
Waliullah is asking something. Waliullah, not more than 2. For final project, you are talking about the submission of the project. You can ask your coordinator, Dr. Asif. You can ask the coordinator so that they will let you know how many people for one project. For this subject, yes, for this.
जिस सब्जेक्ट के बारे में बात कर रही हैं?
If I'm talking, see now if you can ask the project coordinator. You आपके coordinators हैं. I think that Dr. Asif will let you know. How many people they are allowing to be in one project? I have no idea. Yes, class project you can be 2, not more than 2, but 2 means both have learned something. I will ask the questions. I will ask the question. If you are less than 2, it's better. Go for yourself. Better to learn. बेहतर ये होगा कि आप खुद करें, because hard for me to take the presentation. Maybe I will not get the chance to get the presentation. So it's better to go individual. You will learn a lot and then submit the presentation and everything. It's better. I suggest you go individual. So you will learn better because you have no any online classes. You have no any interaction online. So it's better to go off individually. But if someone have any issue, he or she have some issues, you can have 2. I prefer you should be alone. But if someone has issue or cannot unable to understand, you can combine with anyone, not more than 2. So if someone is alone, I assume he has put his own efforts to learn something. Especially who are working in deep learning projects, they should be alone. It's better for them. They will learn so many things. So inshallah, you will get better marks. Don't worry about the marks. Just put your efforts. I want to see your efforts, not the best results, 90% accuracy, 80% accuracy. I'm not running behind the accuracies. I want to see your efforts. If you have put some efforts in the project, you have shown the results in the PPT, you have discussed each and everything, why you use this one, then I will mark you. No issue. So your PPT should be strong. I will mark you without any presentation. Maybe I will not get chance for presentation. It's possible. But if I get the chance, I will let you know. You can present your PPTs. So you make your PPTs for 10 marks for the project that you will submit, and the both of the things. We have we have 20 marks left behind. 10 for your deep learning and 10 for the general project that I given you for pre-processing and everything. So I think you will go for that one. Is there anything, class, that you want to ask?
No, sir.
Okay. So I hope that you will learn a lot. I'm trying best that you will learn a lot instead of just submitting the assignments. So try to learn a lot so that it will be helpful in your projects. And then maybe for further studies, you need these things because you will not get the chance to learn these things in future. Maybe you will not get chance. So you will not go any further studies for MS or anything. So you learn the latest topics so that you will have knowledge of these things. So I'm going to end the class. What's the time, class, right now? At what time it will be over?
Sir, 3:45.
So over, I think its time is 3:55 actually. Okay, so it's over. So I'm going to end the lecture. Any query you can ask right now, class. No, I have to end up the class. Okay, I'm going to stop the class and then you can leave.